So now it's starting to get fun. Now they've given us a normal graph, and they want us to use y equals f of x, and then make it into y minus 6 equals f of 4 times x plus 2. So if we went to try and do it the way we did for example 1, we would be having to do one thing at a time, draw a different graph from, no, let's not do that. So when it says general transformation, what it means is you're going to do all of the transformation stuff at once, just one general one, and then you're going to have your final graph. So it's a little tidier. So they give you a gorgeous, gorgeous formula to use on page 222 of your textbook. And what that formula looks like is y minus k equals a times f of b times x minus h, like that. So basically what we're going to do is we're going to compare this pattern to this pattern and pull out the numbers, and then we're just going to use those numbers to change the points that we have over here. So what I want to look for is the individual number values. So I'm going to write them down here. We've got a k, an a, a b, and an h. And the numbers, the values in front here, positive or negative, have to coincide. So this is easy. Y minus k, it's just like a little Lego block. Boop. The 6 goes in where the k is. So k equals 6. And the next one over, you'll notice there's nothing here. That means it's a 1. So a equals 1, right? We're not going to really have to do too much with that, but we can just write it there to make sure that we know what we're doing. We go into the function, and the first number inside the first set of brackets is a 4, which means that b is a 4. And then the number that is inside the inner set of brackets, and yes, if you want to do this correctly, you need to make sure you've got brackets within brackets, is a 2, but it's a positive 2 where it's supposed to be a negative. So I would switch that sign, and h is actually a negative 2, because if I put x minus a negative 2, it's a positive. So just be aware that we're pulling the numbers out, and if the signs don't match, you have to switch them. Okay, so now we've got our values k, a, b, and h. And what do we do with those? Well, there's another part of the formula on page 222 that shows us this handy trick. Now I know that I've already done these as separate steps. I'm just combining them all now. So it's a super nice little method of taking all of the little bits and pieces that we've already used and putting them all into one. So really what I have to do is I'm going to use this formula. I'm going to go x over b, because that's my stretcher compression, plus h, so the number that's in here, because that's my sideways. And then I'm going to multiply y by my a, which is my stretcher compression, and then I'm just going to add k, which is that one. And the way that they've got these things worked out, the values, the negatives and positives, just follow through as long as you follow the pattern. So we have to customize this by putting in these values. So for my particular formula here, I'm going to have x over b is 4 plus h is negative 2, so I could actually just write minus 2. So that's going to get me my x coordinate. If I divide it by 4 and subtract 2, then my x coordinate will be the new one. And then for my y, I'm going to go a times y. Well, that's just 1, so you can see that it's just 1. I can write 1y if you want to, but it's not really going to do much this time. but you can see where it would be if there was an actual valid number there. And then plus k, so plus 6. So this tells me that I'm going to multiply my y value by 1, whatever, and add 6 to get my new point. So when I do that, I'll write out the first one and then we'll just go through these ones. Negative 4 divided by 4 minus 2, and 12 plus 6. So that's going to get me crowded, but negative 4 divided by 4 is negative 1, minus 2 is negative 3, 12 plus 6 is 18. So I've got a new point at negative 3 and 18. Negative 3 and 18. Then we just keep going. So each one of these numbers is going to go in here. Each one of these numbers is going to go in here. I'm going to get my new value. So negative 2 divided by 4 is going to be, well, negative 1/2. Minus 2 would be negative 2.5. Then I'm going to take my 0. 1 times 0 is just 0. Plus 6 would give me 6. 0 divided by 4 is still 0. Minus 2 is negative 2. 4 times 1 is 4. Plus 6 is 10. 2 divided by 4 is 1/2. Minus 2. If I have 1/2, I subtract 2. I'm only down 1.5. And 0 plus 6 is 6 again. So you see, each time I'm just plugging this coordinate into this formula and getting my new coordinate. So my last one, 4 divided by 4 is just 1, minus 2, it's going to give me negative 1, and 12 plus 6 is going to give me 18. So I can plot that point at negative 1 and 18, right there. Negative 1.5 and 6, right there. Negative 2 and 10, right there. Negative 2.5 and 6, about there. So we can see that the pattern is the same. So I can now join my points with a little sketch. Get those going up that way a little bit more, kind of made a mess, but whatever. So you can see that it's been lifted, it's been shrunk, and it's been moved sideways, but all at once. We only had to do that one thing. All we have to remember is how to apply the pattern. So this is my base pattern. I make sure I pull out the values in the correct order with the correct signs. I list my values. I put them into this equation. And then I use this equation with my original set of points to get my new points, plot them, and I'm done. Now this question does give you one extra little caveat. It wants to know your domain and range. So I would write domain for my original graph. It goes this way. It's just x is in the realm of all real numbers because there are no limits. And my range for that one, y is actually kind of stopped right at the 0 line. So y has to be greater than or equal to 0. I look for my domain and range for my new graph. Still, even though it's narrower, it's still going out just at a lower rate. So x is still going to be in the realm of all real numbers. And my range has just elevated itself to 6. So now y has to be greater than or equal to 6. So you can see that the domain and range have some overlap, they have some similarities, but they're not necessarily exactly the same, which makes sense because we moved it. So this is awesome.